All right, we're going to take a look at section 9.1. Chapter 9 right here deals with trig functions and ratios. So we'll start with some of the basics. Some of the things that right here in 9.1 are things that you've actually learned in geometry. We start off right here with SOHCAHTOA. If you remember, this is a little acronym that we use to help remember the sides that correspond with sine, cosine, and tangent. Remember, SOHCAHTOA. For sine, we have O in the H, which represents our opposite and over hypotenuse. So let's go ahead. Right here, we'll put opposite over hypotenuse. In a cosine ratio, those two sides happen to be the adjacent side over the hypotenuse. And for our tangent ratio, we have the opposite over adjacent. And those are the ratios that correspond with sine, cosine, and tangent. There's a total of 6 different ones. In geometry, you only went over 3 of them. And let's take a look at the other 3. As I scroll down right here on the right hand side, I put these trig functions are inverses of each other. And next to sine, I have CSC, which represents cosecant. For cosine, the inverse is secant. And for tangent, the inverse is cotangent. So it's important to memorize which happens to be which functions are inverses of each other. Because when you take the inverse, you will take, let's say, for example, the sine ratio, which is opposite over hypotenuse. You take the inverse of that, which would be the reciprocal, and the cosecant ratio will be hypotenuse over opposite. Okay, once again, that is the reciprocal of the sine ratio. For the secant ratio right here, or the inverse of that, will be hypotenuse over adjacent. And for cotangent, the inverse for that will be adjacent over opposite. Right, so these right here are the 3 new trig ratios or functions that you're going to need to get yourself familiar with. It's very easy to remember them because just think about what is SOHCAHTOA and then go ahead and take the inverses of those 3 functions. As we scroll down right here, you can see the different trig functions once again, the 6 different ones right here, and they represent and they're showing you the same thing that I just we just wrote down. Now, below that right here, we have another. They show you right here cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta, and cosine theta is equal to 1 over tangent theta. And they're showing you once again the reciprocals, another way for you to write down your different ratios in terms of sine, cosine, and tangent instead of putting opposite over hypotenuse or anything like that. Those will be a little bit more handy as we go later on in the chapter. But there's a little introduction for you right here. So you could also memorize these as well. As we take a look right here, we're dealing with the trig values of special angles. Now, there's 2 triangles in geometry that we've covered, 45, 45, 90, and 30, 60, 90. These are your special right triangles. Now they have all these different sides, and they already have lengths that go with them. And the ratios of the sides will always be the same thing as what you see right here in a 30, 60, 90 and a 45, 45, 90 right triangle. So how did they come up with this? Well, let's go ahead. Let me draw a triangle right here. And so right here we'll go ahead, we'll put this as, we'll make this 30, 60, 90. Okay. And remember, some basics about triangles is that um, the size of the angle will determine the length of the side opposite of it. So this being the smallest angle right here, the 30 degrees, the side opposite of it will be the shortest side. Now, right here, I'll go ahead and write down 30, 60, 90. And what I want to show first right here is that we always say the side opposite of 30 is going to be x, which happens to be the leg. Okay, the x will represent the length of the leg. The side opposite of 60 is going to be x rad 3, or whatever the leg is times the square root of 3. And then the hypotenuse, the side opposite of that 90 degrees, will be 2 times x. All right, so that is the length of all three sides of a 30, 60, 90 right triangle. So what do? Let's make it simple right here. And let's go ahead and say the side opposite of 30 happens to be 1. So let me go ahead and put 1 right here, and that'll represent x. We could choose any number, okay? But we're going to make this simple. We'll start with the basics right here and plug in 1. So that means that the side opposite of 60 will be leg times 3, or 1 times 3, which will be rad 3. We don't have to put 1 times 3 because that's the same thing. And then so over here, side opposite of 60, we have rad 3. And then the side opposite of the hypotenuse, or sorry, the 90-degree angle, will be 2 times the length of the leg, which will be 2 times 1, and that'll get us 2. And then that's how this diagram now looks the same as what was already shown. Okay. Let's go ahead and we could do the same thing for a 45, 45, 90 right triangle. Now, when you think about the angles of this triangle right here, 2 of them happen to be the same. So if 2 of these angles are the same in this right triangle, or in any triangle, that means it's isosceles. So that means that these two sides opposite of 45 happen to be congruent. So let's go ahead right here. I'll write down the angles again. We've got 45, 45, 90, and we'll keep this simple. And let's go ahead and say that the side opposite of 45 is 1. Okay. Now, the ratio for the sides right here happen to be x, x, and then we have right here x rad 2 for the 90-degree side. And so this is how long the sides are in a 45, 45, 90 degree right triangle. So since we said that side opposite of 45 we'll say is 1, or the length of the leg is 1, the length of the other leg is 1 as well, because it's a isosceles triangle, then this hypotenuse will be 1 times rad 2, which is rad 2. So now you can go ahead and see, and as I draw our triangle, it ends up looking the same as what we have right here. So if we look at the table now, well, how did they get 1 over 2 and rad 2 over 2, etc.? Well, what we're going to do right here is let's take a look at this triangle. And well, this says sine theta of 30 degrees. So if we say sine of 30 degrees is supposed to equal to 1/2. Well, remember, sine, and if we think about SOHCAHTOA, it's opposite over hypotenuse. So what you're going to have to do right here is take this 30-degree angle, and then we'll look what sides are opposite and hypotenuse. Opposite of the 30-degree angle is 1, the hypotenuse is 2, and that's how they came up with 1/2. When I want to find the sine of 45 degrees, I cannot use this triangle right here because there's no 45-degree angle. Then we'll go ahead and go over here. We'll come back to that in a second. Let's go ahead and finish this off, and let's say we want to find the sine of the 60-degree angle. Well, we'll take a look at this where the 60 degree is, and then we'll go ahead, we'll look at opposite over hypotenuse. Remember, the opposite side to this angle is going to be rad 3. The hypotenuse is 2. There you go. Rad 3/2 right here. So with the 45 degrees, for sine of 45, I can't use this triangle. I have to go over here and then create, if they don't give you a triangle, you have to make one. And we have to look at this 45, 45, 90-degree right triangle. Now, since they're both 45 degrees, we have two angles. It doesn't matter which one you use, as long as you use the correct ratio. So if we were using the sine ratio, once again, it's opposite over hypotenuse. Now, in this instance, opposite over hypotenuse right here gets me 1 over rad 2. And if you look at this answer, it does not match the one that's already written down. If you recall, we talked about this a few times already earlier on in the school year, is that we have to, or what is it? We cannot have radicals in our denominator. So adding a few notes right here, in case you forgot, no radicals in the denominator. And also, we're not going to use decimals, no decimals. Okay. So what do we do in this situation? How do I get rid of the radical in my denominator? Well, in order for us to do that, what we're going to do right here, if you remember the step, we'll call this rationalize. Rationalize the denominator. Okay? And in order for us to do that, we want to take our denominator and turn that into a rational number. So the easiest way usually is to go ahead and just multiply it by whatever the denominator is. So multiply top and bottom by rad 2. So remember, when you multiply radicals and the radicand is the same, it ends up equaling that same number. Because this turns into rad 4, and then rad 4 is 2. Our numerator now becomes square root of 2. So now you look at here, we have ourselves rad 2/2. And there you go. Sine of 45 degrees is rad 2/2. So if your answers aren't coming up to be the same because you're not getting the radicals down, or if you're saying they don't look correct because you have a radical in your denominator, then you need to go back and rationalize it. All right, let's go ahead and take a look at how we could answer some of these questions here. Looking at number 1, it says in exercises 1 and 2, we'll evaluate the 6 trig functions of angle theta. So I have my right triangle right here, and if you notice, they only give you information for 2 out of the 3 sides. And they want us to evaluate 6 trig functions. Remember, the trig functions, one of the things that you need to know in SOHCAHTOA is we need to know what the hypotenuse is. And if you look right here, I do not have information on the hypotenuse. However, you can figure that out by using the Pythagorean theorem. So let's go ahead, we'll start off, use the Pythagorean theorem. We got 8 squared plus 15 squared is equal to c squared. Remember, a squared plus b squared is equal to c squared. 8 squared is 64 plus 225 is equal to c squared. We have 289 is equal to c squared. And when we square root both sides, c is equal to 17. All right, so we figured out what the length of this side right here is. Okay, I want to clear all this stuff out so we could put our answers down. Now, if you're real good, you would have remembered that, hey, this right here is a Pythagorean triple, 8, 15, 17. So if you had that down and you had that remembered, like 3, 4, 5, that's a Pythagorean triple, then you wouldn't have happened to do all that work. But there are going to be times where you have no choice but to use the Pythagorean theorem. So let's go ahead and figure out the 6 trig functions right here. So let's start off with sine theta. And don't forget, we have SOHCAHTOA. So sine is going to be opposite over hypotenuse. Opposite over the theta, right? Angle theta is 15. And then the hypotenuse is 17. So there's sine theta, 15 over 17. Cosine theta, we'll take a look at that angle again. And then we have ourselves adjacent is 8, hypotenuse is 17. And then we take a look lastly at tangent for our first 3. And then tangent is opposite over adjacent. Opposite side is 15. Adjacent side is 8. And as we take a look at my 3 ratios, I don't have to do any simplifying. So we'll go ahead and keep it as is. If you have to simplify, you want to make sure you do that. Once again, no decimal answers right here. Okay. So now let's think about, well, what are some of our inverses? The inverse of sine is cosecant. So we'll have cosecant theta. And remember, all you need to do is take the inverse. So, or the reciprocal. And so the reciprocal of 15 over 17 will be 17 over 15. The inverse of the cosine ratio is secant. So we'll have secant theta is equal to 17 over 8. And then cotangent theta is going to be equal to 8 over 15. Remember, all of these are reciprocals of each other. Okay, when we take the inverses, you just need to go ahead and take the inverse of each ratio to come up with your answer. So you don't have to technically think about SOHCAHTOA and then say, all right, cosecant is hypotenuse over opposite, and then find hypotenuse over opposite. You could do that, or you can go ahead, if you already have 3 of the basic ones down, then you just need to take the inverses of and the reciprocals of each respective function. Okay, let's go ahead and move on down to number 3. So they're saying right here we want to find the 5 trig functions of theta. Because they gave you one of them, they said the first one right here, tangent theta, is equal to 1. Now I went ahead and drew a right triangle right here. And let's go ahead and try to figure out, make use of all this information. Now let me go ahead. I'll make this angle right here theta. It honestly doesn't matter which one we make theta, whether it's this or this. What does matter is how we interpret the information. Now, once again, let's think about our ratio, SOHCAHTOA. And for tangent, it's going to be, if in terms of this theta, it's going to be opposite over adjacent. And what they're saying is that if I take this side, the opposite and adjacent side, if I divide them, it's supposed to equal 1. Well, there's many ways we could divide two numbers and get 1, right? I could have 5 divided by 5, 10 divided by 10, 1 divided by 100 divided by 100. So why not make this easy and make these two sides, how about we'll just say that it's going to be 1. So I'll go ahead and put 1 right here for opposite and 1 right here for adjacent. And if I were to set this up and say tangent theta is equal to 1 over 1, that does happen to equal what we have right here. And so if we put the pieces together, this actually happens to be what type of a triangle? Well, if these two sides are congruent, it's another 45, 45, 90-degree right triangle. All right. So then what we need to figure out is, well, what happens to be our hypotenuse? If this is a 45, 45, 90-degree right triangle, remember, let me write this down again. 45, 45, 90. Remember, side opposite of 45 is x, x rad 2. And if we're going to say that one of our legs happens to be 1, then we can go ahead and put 1, 1, and then rad 2, or 1 times rad 2 for the side opposite of 90 degrees. And now we have all 3 sides lengths figured out for our problem. Okay? So let's go ahead and move on right here. Let's figure out sine theta. Remember, sine is opposite over hypotenuse, which happens to be 1 over rad 2. And hopefully you remember that we can't have our answer like this, so we'll have to go ahead and rationalize it. So let's rationalize our denominator. We'll multiply top and bottom by rad 2, and we're going to end up with rad 2 over 2. So there's sine theta. Let's go ahead, we'll go to cosine theta. Adjacent is 1, hypotenuse, rad 2, and we can't have a radical in our denominator, so let's go ahead, and we already did the work for sine, and we can go ahead and put our answer down as rad 2 over 2. Alright, so we got sine, cosine, and tangent. Let's go ahead and find the inverses of them. For tangent, remember the inverse for a tangent ratio is cotangent. And we'll go ahead and the inverse or reciprocal of 1 over 1 is still going to be 1. So there's cotangent theta. The inverse of sine is cosecant. And cosecant theta, if I take a look at the very first one we came with, the answer was 1 over rad 2. If I take the reciprocal of that, it's rad 2 over 1, or we'll go ahead and put it as rad 2 as that answer. And then for the inverse of cosine, we have a secant theta, and that is going to be equal to the same thing of rad 2. You could take rad 2 over 2 right here and take the reciprocal of it, but then you have to rationalize the denominator again and add another step. If you take the first answer that you come up with before rationalizing, hey, you could go automatically take the reciprocal of that, and then you won't have any radicals in your denominator. All right? So that's what they mean when they're asking you to find and evaluate the 5 trig functions. They give you some information to help you find the first one. Remember, since they said that tangent of theta is equal to 1, I went ahead and drew theta right here and figured out the sides for it to equal 1, right? I could have put 5 over 5 because that still equals 1. And then this hypotenuse would have been 5 rad 2. So you can make it easy or you can make it hard depending on what you want to do right there. Okay? Let's say, for example, I got number 4. How about we'll just set this one up? If we have our triangle, and we'll go ahead, this is theta right here. What they're saying is that sine is 3 over 19. Remember, our sine ratio is opposite over hypotenuse. So the opposite side of this angle would be over here, and that's 3. The hypotenuse is here, that's 19. And that's how you find the sides. In order to find the third side, you're going to have to use the Pythagorean theorem. And then you go ahead and do all the work right here. All right, let's take a look next up at number 5. So to find the value of x for the right triangle, once again, we're taking a look at this triangle, and one of the things that you need to begin to pick up is the fact that this is one of our special right triangles. This is a 30, 60, 90 right triangle. And remember, we have 30, 60, 90. We'll write that out. Side opposite of 30, we put as x, or the leg. Opposite of 60 is x rad 2. Or sorry, we have ourselves x rad 3 right here in 30, 60, 90. And opposite of 90 is 2x. So if I look at my diagram, what I have right here is 16. The 16 is the side opposite of the 90-degree angle, which is our hypotenuse. If I'm looking right here, I'll focus on this. What we're saying is that the side opposite of 90 is equal to 2x. Well, if I know that an entire side is equal to 16, what that allows me to do, and what I can do, is set 2x equal to 16. If we go ahead and solve for x, x ends up equaling 8. Now, you have to remember that this right here, what I got for x, does not represent this side. Okay, what it represents is the leg. Right? X right here, in terms of what we put down, x represents the leg. So what I can go ahead and figure out is that if they did ask for the leg or side opposite of 30, then that answer would be 8. Now, what they're asking me is, what is the side opposite of 60? Well, it's going to be whatever the leg is right here times rad 3. Just like that, we got our answer. Okay, so 8 rad 3 happens to be the length of the side opposite of 60. So you got to figure out, well, what are the sides of a 30, 60, 90 right triangle? Figure out the missing length based on what they give you, and then fill in the rest. And the side opposite of 60 is this x rad 3, or leg times rad 3. And we had to use a hypotenuse, and that helped me find what the leg is. Let's try the last one right here. We have ourselves, I look at this, I've got 45, 90. That means that this angle happens to be 45. So we have another special right triangle. Remember, we have ourselves, if it's 45, 45, 90, it is an isosceles triangle. Side opposite of 45 is 20, right? So if it's isosceles, remember we have two sides that are congruent. So 20, 20, or actually even before we get to that part, remember it's x, x, and an x rad 2 for a 45, 45, 90. That's how long the side lengths will be. So if the leg is 20, 20, our hypotenuse right here is going to be the leg times square root of 2, or 20 rad 2 right here. And then there's your answer. Because they're asking what is this side, which is our hypotenuse. And there you go. 20 times rad 2, and there's your answer. All right. Hope this was helpful, and I'll see you in the next lesson.